Hello, everybody, and welcome to Sparring Partners. I am Monica Paolini from Sensophilia, and I'm your host today. And with me today, I have the pleasure to talk to Siavash Alamouti. He is the co-founder and executive chairman at Mimic. I've known Sivash for a very long time, since the WiMAX days when he was at Intel. But in fact, I know Siavash as a code before I knew him as a person. So the first time I met him, I thought, well, this name sounds familiar. And so it was kind of interesting, and maybe you can explain that. But anyway, it was great to work with you back then, and now on something different but somewhat related as well. So, Sivash, why don't you introduce yourself and tell us who you are, and by the way, today we're going to be talking about many of the facets of AI and the complexity, what it can do in probably a new kind of approach and perspective. So, Sivash, tell us.
Monica, it's a pleasure after so many years. My history, I'm a wireless communications engineer. I've been involved from early days, from CDPD, 2G, 3G, as you said, most well known for the invention of the Alamouti code, which is in billions of wireless devices today. That's what people know me for. But really, in the last decade, I've been involved more on cloud and the evolution of cloud. Because as you recall, I've always been a proponent of technologies that can scale and they're cost efficient. When I promoted Wi-Fi, I quit AT&T to go and start working in startup for Wi-Fi, and then joined Intel and did mobile WiMAX. In the last 10 years, I realized the big issue would be the cloud and scaling it, because of the way nature of traffic was changing, and we were generating more data on the edge, and we would require intelligence on the edge. So I co-founded Mimic with Faye Arjumandi. So in the last 10 years, I've been focusing on distributed cloud and cloud architecture. That's what Mimic is all about. And the company's really name, Mimic, the branding, was mimicking human behavior on devices, meaning bringing cloud capabilities, cloud server capabilities, and intelligence onto a device. So making a device kind of act like a human. Right now, the cloud architecture resembles still the days of mobile internet, where we would make the first API call to a server in the data center in order to extract information and from the cloud. So most of the workloads are running on servers in data centers. And so we came up with this concept of hybrid edge cloud, HEC, which got published in 2022 in IEEE Communications magazine, about this cloud device first or edge first interpretation. Of course, a lot of confusion around that, where the edge is. What Mimic does is very different than, for instance, what Qualcomm and Ericsson and the telco community calls hybrid edge cloud. For them, edge is the edge of the network. For Mimic, edge are these devices, robots, drones, sensors, being able to make the first API call to themselves and saying, oh, can I manage this workload? Yes, let me do it. No, I'll go to a edge gateway nearby, or I would go to a server and data center, or I would go to a GPU farm, and run my workload. But the decision where to go to do the workload should start from the device. And that's what we call, operationalizing agentic economy.
Yeah, and this is really interesting as we talk about then AI, because it's like AI, but in a device, but you have this huge model. How do you do that? But let me say, the first time I heard about the edge cloud, I thought this is an oxymoron. Is that an edge or is it a cloud? What is it? So maybe because we often think about the cloud as something that is centralized, so what I now call a centralized cloud, right? So can you explain it? Can it be
Sure.
cloud and edge?
Sure, absolutely. So if you go back to the history, the reason we did cloud is so that the developers wouldn't have to buy their own servers, and they can easily get access to servers and then host the workflows. So the front-end applications just collected prompts, information, and then most of the intelligence would be on servers in the data centers, and you would download information. So you make the apps really cheap to build and maintain, right? So that was the entire premise of cloud. And one of the most important innovations for that were APIs and microservices that would bring massive efficiencies to resource sharing and also to memory efficiency on running these workloads, because serverless architecture, you would only put in memory and consume energy those elements that were active at the time. So this was absolutely key. Now, when you come to the world of AI and agentic, that picture changes a lot because context becomes really important. So a robot, right, carrying on a task, it would be very expensive it's terabytes of data, for instance, for autonomous vehicles, or hundreds of gigabytes of data for a robot doing very particular thing in transmitting its context. It's like Monica trying to transmit her feelings and put it in data format and send it before she takes an action, right? So that's why we figured that it's a different architecture that is required, where you have the context, you as a robot, you decide what you need to do. You can't orchestrate these things. It's more about choreography than orchestration, because you can't possibly predict every nuance of what's going to happen when you're trying to do your work, right? And then do it if then else, right? That's why this architecture, where you have an API gateway on a device, you make your first API call to yourself. You know your resources, nearby, and then you can collaborate and then use cloud resources, third-party resources as needed, as opposed to sending all of this information to a third party and for them to tell you what to do, right? It would be the equivalent of me making a first API call to Monica and say, Monica, I'm hungry. What should I do? And you say, oh, Siavash, you should eat, right? that model doesn't work. That's the model of the cloud today. You should be
It's like
saying,
telling you
I'm
what to eat.
hungry, right?
Yeah.
And Monica, by the way, you're a better cook than I am. Can you help me? Or no, I'm a better cook. I'm going to cook for both of us, right? That's a more natural way and more efficient way of running these agentic the workloads. And that's why we did Mimic, right?
Yeah.
We brought the
And I guess
technology.
yeah, so it's like me telling you what to cook without looking at your fridge, right? Because if I know what you
Exactly.
have fridge, I know exactly what I mean, or whatever, and in fact, you don't need me to tell you, because if you look at your fridge, you can figure it out instead of me looking at the whole database of what you could possibly cook in the world and then sending you shopping to buy what you need in order to do that. So, and I think that this is actually something that intuitively all these big models are lacking today, is that they do not extrapolate to context. So I'm using the same model every day, say, but it doesn't learn anything about me. And that's really would save them so much resources if you just like forget about what the rest of the world is doing, or what the world, use the context of who I am and what I care, which is actually kind of pretty obvious. I mean, every human is kind of limited. Well, limited. You have your own, things. So if I know what you like to eat, it's very easy. But if I don't, I'm just going to be. It's a much harder problem, right?
Oh, absolutely, absolutely. I
So
love actually your analogy of not knowing what's in my fridge, because I would have had to take inventory of my fridge
send
and
it to
send
me.
it to you. And that's where the lack of efficiency, latency, data privacy, and all of that, because I may have things in my fridge that I don't want you to know. Right?
Exactly.
Exactly. I know for me to send all of that information to you or be selective about what I send to you is very inefficient. It's an
Yeah.
absolutely
Yeah.
beautiful analogy. Yes.
Yeah. So, okay, let's just talk about, so what does that mean in terms of having everything on the device? Because at the same time, you do not want to build the model in the device because the device is obviously limited. So, and I think that that's the hybrid part that, you can train your model on whatever data center, it doesn't matter, it just learns it there. But then you extrapolate what is relevant to you, your fridge,
Right.
your whatever, and then you get it onto your device, which is manageable and
Eh,
much.
eh,
And I think that,
Exactly.
okay, we'll get to the telecoms later, but so what's the balance here between what is it you do in the centralized cloud and what is it you can do onto the device?
This is exactly, that's why I love the analogy of Wi-Fi to cellular, right? Because the argument was we should, if we have a wired connection, high-speed connection, and we're doing things locally, we shouldn't burden the broadband network. We should just do it locally because it minimizes interference, and that way you scale capacity beyond what licensed spectrum would provide you. So the same argument holds for these agentic workloads. So Siavash wants to do certain things, right? I want to be able to lift a 1 ton object, right? I know that I can do it. I make a call to myself and say, okay, I need to lift this thing. Okay, Monica's here. Can the two of us lift it? If it's 100 pounds, sure, the two of us lift it. If not, I'm going to have to call a moving company to come and do this. The same holds true with these agentic workloads. It's exactly that. I look at my own resources first. I try to do, and usually the workload is that it has a Pareto distribution. In fact, I'm publishing a paper that just as after before we talk, I got an ArcSiv indication that it's ready to publish. Most of the, if you look at the agentic workloads, over 80% of it are very small tasks, and 20% of it requires high power computing, GPUs and all of that. Most of these things can be done on the cloud. So I do whatever I can locally with the context that I have, and then I delegate the rest to the cloud. And the savings of it, I modeled it mathematically, I did Monte Carlo simulations, and that's what is getting published. On the average, it will give you 80% savings in energy costs and cloud costs. Why? Because you apply the same microservice architecture that you do on the servers, you bring it to device. So memory savings, it takes much more energy to send data over RF than do simple compute locally on the device. So, and all those calculations, mathematical models, Monte Carlo simulations are there. What does this mean? This means that when you do this, first of all, what do you require? You require a operating environment where you can run microservices, right? That's one aspect. And this should be above the operating system because you want it to run on anything. You know, you want it to run on iOS, Android, Windows, Mac, Raspbian, you know, a microcontroller at the end of the day. So you need that operating environment that is very agile. You need an API gateway, and then you need the ability for nodes to be able to discover each other. I need to be able to see you, Monica, to be able to collaborate with you. I should be able to discover you and be able to have a communication at a workload level. Meaning, Monica, can you give me a hand to lift this? And if you say, I've never lifted anything, I don't know how to do it, I have to have the ability to tell you how to do it, right? And that's pushing a microservice from myself to another node. So these were some of the fundamentals. So we looked at this from a first principle design perspective and said, what are the requirements? And we started building it. And that's why it took us years to complete something like that securely. I have to make sure that everything is trustless because any node should be able to authenticate any other node. All the data needs to be secured and all that, right? So those are the aspects of what you need. And then in terms of capabilities at a high level, it's the ability to discover each other, the ability to push workloads to each other, to learn each other. Just imagine one robot from one manufacturer needs to work out with a robot in another manufacturer. Sometimes they require some sort of real-time integration. You can't do this through the cloud, right? And say, hey, here is a microservice. I'll give it to you. And by the way, you gotta have to pass me a few tokens because I need to get monetized for this, right? So these are the kind of basic capabilities that we built in the Mimic platform, and now we've applied it for agentic. We have applied it to some vertical use cases like marine industry, automotive industry, and it's now gaining ground. So that's what the
Absolutely.
story of Mimic is.
This is so interesting because, you know, if you look at it from the wireless telecom perspective, so obviously you have a latency issue that if everything is in the cloud, at some point you run into too high latency. But also there is a transport and access capacity issue that the more you go back and forth, the more network capacity and resources you need, both at the access and transport level. And then there is the issue of power consumption. So there is all this idea now that you need nuclear power to get AI to work, which I mean, I'm not saying that. I'm not saying that. Obviously, we're going to need more power probably, but I think that the logic that dominates when I talk to people that is that everything is going to scale linearly. So the more AI, the more power consumption there is going to be through time. And to some extent, that's going to be, sure, it's going to increase, but it's not going to be linear because you're going to become more efficient.
Right.
And you're going to be using AI to become more efficient. Otherwise, what's the point of it, right? So what we use today to power our models doesn't necessarily mean that this is what we're going to be using in a few years from now to do the same thing, because you're going to get more efficient. And what you're trying to do probably just take us there, because instead of doing everything in the cloud back and forth, and you do it in the devices to the extent that you can, obviously that's going to be so much more energy. It's sort of like, it just seems like
Absolutely, absolutely. You see, the reason we got to that architecture, Monica, was like if we look at the requirements, we looked at and say, okay, let's look at autonomous vehicles and let's look at, say, robots and drones with intelligence. How much data do they generate, right? That needs to go back to the cloud or to an edge gateway or whatever in order to process. We did that first calculation, right? And actually, I've in my talks, I've shown some of those results. And they said, okay, if I had all the capacity of wired and wireless networks today, how many of these autonomous vehicles and robots could I actually support with the current networks? And then if I wanted to scale this to the billions that people are talking about, how much more capacity would I need, right? So when we did that, it was, I don't remember this in my talks, but it was in tens of millions, right? So the entire capacity of the current wired and wireless networks could support maybe a couple of million autonomous vehicles and no, 20 million robots and drones. So we need 10 million times the capacity or something like that to to do these to support these robots and drones, semi-autonomous things that are supposed to work together and enhance our lives and collaborate with us, which was obviously not doable for a
it's not
communications engineer. We know maybe 10 times every generation. So it's going to be centuries before we can do that. So that's
yeah.
why we needed a new architecture. That's and then we came up with the right architecture for that.
Which is why there is a little bit of doom and gloom, because people say, well, but it's not going to scale because of, the kind of computation that you did, because if you go
Yeah,
that way, it's just not going to work. But obviously what you're going to say is, we're going to do is like, okay, let's see how we can get it to work, given that this is not sustainable. What's the alternative? What is that we can do to, you know, to be able to take advantage of AI without become victims. And this is when you look at network optimization, there is the same thing that a lot of people say. If you assume that you use a large language model, like the huge things, the chat GPT kind of things, and use that to optimize a cell site, well, yes, it is going to be a problem. The latency, everything, but that's not the way you want to go. You just want to have a more limited model.
absolutely,
That
absolutely. You see, that's the big thing that people are missing is that the large language models and the investments that has gone, billions of dollars of investment that has gone through it, was fundamental, was absolutely essential. But now using these large language models and reducing the language model to become expert in one field, to be able to run it locally is absolutely feasible and viable, right? Then this is something that, for instance, you saw with DeepSeek. And it's not the first one. It's many of these things. The small language models are where real efficiencies are going to come in. Because to
Yes.
think that you're going to run large language models for every task that you do, that's not scalable. There are
No.
numbers on these things that every prompt to a large language model is probably around 20 liters of water in terms of energy.
Yeah.
They just ignore the costs and tokens of integrating these, all of that. But this is not scalable. So
Not
you
only that, but also less accurate, because obviously
right,
the more you restrict the search space or your database, you're gonna be much less likely to have, like, the hallucination problem or inaccurate. The more you constrain the data, not
yeah,
only is more efficient but also more reliable. So it
absolutely,
just seems like
absolutely.
you know.
So this is kind of something that people don't have the entire picture of. Then they mix, for instance, pre-training, post-training, and then optimization of inference. The time performance thing. These are the three stages, and often these get mixed up.
Yes.
Billions of
Absolutely.
dollars of investment went to the pre-training, building these large language models with OpenAI, Meta, and Google, and massive amounts of investment that was done. The post-training to make these models smaller can be done by smaller entities with lesser compute resources. And then optimizing the inference is a combination of both, because you require high power computing along with the ability to run these inference models locally, right? To optimize it further, to make these agents really efficient and make
Yeah.
the model work, right? Because if you're spending more money to automate these things, that's something that can be done manually, it doesn't make any sense. That
No.
optimization, that third stage is absolutely essential. And for
Yeah.
that to work, you have to reduce costs significantly. And all of these stages are required.
But also, as you say, the initial work on these big models is absolutely essential, has been absolutely essential to take us where we are today. Which was actually quite amazing that they were able to do it on so much knowledge. Again, huge models, but it's amazing what they can do. And so we need to extract all the information. So whoever now does something, it's going to be benefiting from all the work
Right.
that the other initial companies like OpenAI has been showing the way. And now, I mean, you could say, well, maybe they're benefiting from in the same way that everybody does in
Yes,
technology science, you build on what has been done before. And so maybe you could
absolutely.
tell us about
Absolutely.
what the DeepSeek kind of issue is telling us and teaching us, because I think that there has been a lot of panic, but maybe we should try to learn from it. What is the learning here for industry?
Yeah, to me, it was really astounding. Last night I wrote an article on LinkedIn, and I was astounded because I first heard of DeepSeek when what they've been doing in November. I started looking at blogs, chats in the
Actually,
AI
why don't we,
community.
Siv,
Right.
why don't you just say what it is for if people don't mean, I'm sure that pretty much everybody knows, but can you just give us like
So, so
a very,
sure. There was an announcement when there was Trump's right after Trump's inauguration, that DeepSeek had come up with this large language model that was extremely efficient, and it worked better than ChatGPT-4 for certain functions, blah blah. And it was done only with $6 million of investment by a Chinese company, right? That was the big news, right? So the reality behind it is that we people that are involved in the AI field, we had heard about DeepSeek, right? And there are many similar initiatives for smaller language models with expert capabilities that is ongoing. What we were shocked at was when this news uh, spread out and impacted took away $1.2 trillion valuation from stock market with the announcements, right? That was really astounding to me. It was very concerning because it was full of disinformation, right? No doubt DeepSeek had done a good job in creating a narrower language model that was great in doing certain things, but the rest of it was all disinformation. The fact that this was built with $6 million was a apples and oranges comparison, right? People not understanding the cost of pre-training and post-training and comparing two completely different things with each other. For instance, ChatGPT 3, the cost of post-training to do ChatGPT 3 in computing was $10 million. It wasn't billions of dollars, right? So that's what DeepSeek had done. It had built on top of all this knowledge, billions of dollars of investment in US, Europe, globally on AI, applying some of these techniques to create a more efficient model to do certain tasks. It's not, DeepSeek is not as powerful as ChatGPT 4. It's constrained. It can do certain things better, right? And so it could be done in a shorter time. And there was other disinformation about them not having used NVIDIA GPUs, but they had in the past tens of thousands NVIDIA GPUs have been used to build to that success. So ignoring all the past and just focusing on the post-training optimization that DeepSeek had done, ignoring the government of China and its ability to promote these technologies out, to be able to roll it out and get usage. Because when you get to the third stage of inference optimization, it's the amount of data that you pull in. Of course, they can, China has a big population, and the state has a lot of control to be able to promote the technology out and refine things. All of these things were ignored, and it was, announced that somehow the Chinese have figured out how to do better AI than Americans and Europeans, which is complete fallacy, right? AI is a global thing that is built on top of years, 50, 60 years of fundamental research and billions of dollars, tens of billions of dollars of investment, mostly coming from Western countries in the US and Europe, right? And now we're seeing the fruits of it after these many years. But still, we have massive challenges in operationalizing it, running these inference models in an efficient way. It's the job that requires a full ecosystem. It requires NVIDIAs of the world. It requires AMDs of the world. It requires software companies. It requires startups. It requires Chinese companies. It's a global thing. It's not something that now is going to get dominated. So I didn't see any justification for, shares of NVIDIA to go down because of that announcement. In fact, I would have thought if they were smart, you would say now inference will require a lot of high power computing. Look at what can you do, and that should tell you that you should buy more NVIDIA shares, not dump them. So this is
Yeah, because if you make it AI more usable, then you just enlarge your market. And at the same time, that's part of the sort of the NVIDIA and the chipset company is to make everything more efficient. So if you get more efficient, it's kind of and as I say, there's been decades of research. And so, and sometimes people think about we need to have US or Western or whatever, sort of limited geographically. It's just not going to work because all of this, all the algorithms, all the way it works, it's pretty much public. I mean, everybody obviously does it in a different way, but the kind of foundation is not really proprietary to any country or to any company. And so the question is who does better? So I think that DeepSeek is actually helpful because it's going to tell us that we're going to have a more variety out there. And I guess that what you guys are doing is kind of like the opposite extreme of the large language model in a sense of being something much more limited, but much more suitable to to do specific tasks, which do not require worldwide knowledge. And so I think that this is actually a useful thing to come to terms with. Not to come to terms with, but to welcome.
Exactly. So see, what we focused on was a completely different problem. We didn't try to solve the pre-training, post-training need, but there were large, really credible companies with amazing hardware capability that they were focused on that problem. We didn't want to reinvent the wheel. We wanted to build on top of that. What we focused on at Mimic was to make sure that given the Pareto nature of these workloads, that some of them can be done locally, just like Wi-Fi. We can do most of the, wireless communications on back of a fiber network or a cable network with wireless LAN. So we wanted to create that kind of environment where you can do 80% of that workload and bring 80% efficiency beyond training, beyond post-training, beyond inference model, and be able to do these things much more efficiently to make it cost efficient, right? That was our focus, right? The DeepSeek was actually, should have been a very good news for the entire AI community to say, hey, you don't need large language models for everything. Large language models are fundamental, but we can use those to build narrow models, right? With techniques that we have and making inference feasible, because otherwise inference wouldn't be feasible. That's what DeepSeek has proven. And it's not the only example. There are many examples, of people building these small language models. But instead, it was completely misrepresented to saying somebody has found a way to do things that took billions of dollars to do it in millions of dollars. It's just insane. That was hence the impact on the stock market and really good companies losing valuation. I'm
No,
not as concerned about NVIDIA. NVIDIA is going to pick up, but God knows, and certain companies may go may go bankrupt because of it for no reason.
well, yeah. Again, I know. I hope not, but I guess it's kind of like the geopolitical tensions, the timing of it that kind of didn't really help. So hopefully, it's just a blip from which you can
I hope
learn.
so.
I just
I
have
hope
a
so.
final
We need to
question.
be very, very conscious, and that's why I decided to speak up immediately and talk about this. I see this timid approach, and I saw that in the Wi-Fi days as well. There were people that are not willing to talk loudly because they used to work for telcos, for instance. They believed in Wi-Fi, but they couldn't speak up. You see the same thing these days, that people are very reserved when they see. Really, my message to them is that let's go back to the fundamentals. Let's speak up. Let's be direct, because the landscape of AI is so transformative that it can be completely destructive if we don't do the right thing. It can be a dangerous, tool in the hands of many if we don't take the right direction of how this evolves. It
No,
can.
absolutely. And you're absolutely 100% right here that we really, because the change is inevitable. And but it's up to us to benefit from it rather than suffer from it, because there is a huge potential for things going bad. And so we need to have much more, well, I guess we cannot afford to be ignorant about it. That's if I,
Absolutely.
you know,
Absolutely.
we need to spend the time to try to understand how it works from a regulatory point of view, society point of view. It's not just the technology and financial point of view. So this is all. And your article on LinkedIn is excellent. So we'll put a link onto the description of the podcast. And I have to let you go, but this has been an absolutely
Thank-
excellent conversation. So, Siavash, thank you so much for talking to us today.
Thanks, Monica. It was a pleasure. Okay. Look forward to other opportunities. Take care.
Excellent. Well, thank you so much, and thank you all for listening to us. And as I said, I'm going to put links so that you can find out more about Mimic and about DeepSeek. Thank you so much.